Hello everyone. I'm going to explain about our research outcome, which is based on smart materials. So welcome to the world of Auxetic foams. So our primary focus of research is on rehabilitation applications. There are many rehabilitation applications, but we are primarily focusing on only three, on which is on wheelchair seat cushions, stump socket interface, and hospital mattresses. So we'll come from right to left. First, let's see what are the problems in hospital mattresses. If the cushion is too soft, it undergoes sagging, no proper back support, causes back pain. If the cushion is too hard, it distorts our back and pressure concentrated only on two areas, which is on shoulders and pelvic region. So, and if you see the wheelchair seat cushion users, there are some regions which is completely like exposed to interfacial pressures like uneven pressure distribution as well. So these pressure, because of these pressures, the wheelchair seat cushion it undergoes to risk of high pressure ulcers damage when seated. So in order to avoid that, there should be a smart material. There should be an ideal smart material which could reduce these problems in wheelchair seat cushion users. So here for prosthetic limb user, so there is for prosthetic limb users, before wearing any artificial limb, they are wearing one small foam layer called liner. So this liner will improve the uh, comfort of a prosthetic limb user in order to enable the stress distribution and like distribute the forces throughout the limb, so that when during the activity like walking or jogging, or like I mean any activity, so he will get comfort by just enabling the stress distribution. Even though the current liner materials exists, but there are problems like blisters, edema due to restricted circulation, blisters due to shearing, and skin maceration. So these are the problems, common problems which they are undergoing. So in order to reduce this problem also, there is a need of ideal cushion material. So the common problems like pressure ulcers, and these problems are occurring due to uneven mechanical properties like uneven compression, shear, indentation, high temperatures. This causes sweating. So due to sweating, the bacterial and fungi growth are happening between the stump and socket interface, and also the fatigue. So these are the problems. So because of this uneven mechanical properties, like I mean, there should be like proper like mechanical behavior, and it should enable the stress distributions. So because of this, there is a like this like biological skin breakdown is happening due to mechanical properties. So there is a need of a ideal cushion which should give the and which should give the stress distribution and good indentation resistance in order to get a comfort to the patients or users. So hypothesis: can we use auxetic foams? Auxetic is nothing but a word which is derived from a Greek word. I mean a Greek word. So auxesis is nothing but uh, we are going to see in the next slides. So first thing, auxetic foams. What is auxetic? It's a Greek word, and it is a negative Poisson's ratio forms. So let's see what is this like. What are auxetic forms? So any material, when we stretch in these two directions, it will like reduce its thickness in the lateral direction. But auxetic forms, when we stretch in tensile direction, like it expands in lateral direction, which is very strange behavior. So let's see why it is like this. And why this auxetics? Why only this auxetics? So first thing, it has high indentation resistance, good bending behavior, and good fracture toughness, and good stiffness, and at the same time, good stress distribution, which is very important in case of cushions in rehabilitation applications. So there will be an acoustic damping, and there should be a high indentation resistance, which is very important in the case of rehabilitation applications. So we can see here we have successfully fabricated auxetic forms. So left side is an auxetic form. This is nothing but a compression factor. So we are changing the normal forms into auxetic forms by just using the triaxial compression method and heating method. So these are the method which is on from like adopted from a literature, but we have tweaked and we have done is so many trial and error methods, and then found this compression factor is a good for conversion the normal foam into auxetic foams. So we have induced for the first time, we have induced biodegradable, I mean, we have induced the biodegradability and antibacterial together in one foam, which is nothing but we have added castor oil, which makes the foam into a biodegradable, and we are adding at the same time silver nanoparticles, very less amount of silver nanoparticles, which is 1% in polyol, uh, like I mean in polyol blend. So like along with this, we are just in like incorporating the auxeticity so that we are getting a single form which is having biodegradability, and we are like very concerned about our environment. So we are making the forms into biodegradable, and also the silver nanoparticle, like I mean antibacterial, by adding the silver nanoparticles. So our expected outcome, I think we almost reached it, but we still saying expected outcome because there is a need of there is a need to do lot of tests in order to confirm before going to the human trials. So I have mentioned here expected outcome, but I I can say that we have reached up to 90% of the output. Like just want to do before going to the human trials, we need to do some more tests. So here for ideal cushion, it should be cost effective, and it should provide comfort, and it should be environmental friendly and antibacterial. So we have achieved antibacterial by adding silver nanoparticles, and by it's an environmental friendly forms by adding castor oil content, and it's cost effective. We are trying to make this, instead of using silver nanoparticles, we are planning to use the other nanoparticles. And then comfort, because auxeticity will improve the comfort by enable the good stress distribution compared to the normal foams. So the principal investigator for this project is Dr. D.S. Mohan Verma, Assistant Professor in Mechanical Engineering and CBCMT, and the PhD student, it's me, Chaitanya Vinay Valivarthi. So this is the, and thank you so much. And thank you so much. The most positive vote from 2020 is negative, but we have started negative Poisson's ratio materials called auxetics. And thank you so much.